So a like term has the same variable. For example, right, like x, n, k, and then the same exponent on the variable. So like an x squared and an x squared, right? 2 is the exponent there. They both share that 2. So for the first one here, you've got negative 6k plus 7k. We know they're like terms because they both have the same variable k, and they have the same exponent on that variable. Technically, it's one that you can't see, but so they're both k to the first powers. Now, how you put them together is you combine their coefficients, which are the numbers being multiplied out front. So negative 6 plus 7 equals 1. And then you tag on that variable, k. So the answer is 1k. I will go downwards. So now I'm looking at 2 12r minus 8 minus 12. So now there's 3 different terms, 12r, negative 8, negative 12. Not all of them are like terms, right? I only see one term that has a variable at all, r. None of the other terms have r's. So instead, you look for what you can combine. And I notice that both negative 8 and negative 12 have no variable. They're called constants, but obviously you just know them as numbers. So what is negative 8 minus 12? It's going to give you negative 20, and we still have this 12r here. So it's just 12r minus 20. That's going to end it because those are no longer like terms. I can't put 12r and negative 20 together. Looking at number 3 just takes it to that one step further. I now have 4 different terms, and you'll actually have 2 separate times that you're combining. Okay, so first I'm going to look at, I see n, and I want to find the like term for n. Is it the negative 10, the 9n, or the negative 3? Well, remember, like terms again, same variable, same exponent on the variable. So n's variable is n, so we also need another n. So we're going to put together n and 9n. Your invisible coefficient, if you ever see an exponent, or sorry, a variable on its own, there's technically a little invisible 1 on it. So you're just doing 1 plus 9, that's 10. Don't forget your variable, n. And notice we still have a negative 10 and a minus 3, and those again are just numbers, constants. So negative 10 minus 3, negative 13. So the answer for 3 is 10n minus 13. Alright, and then from here, it kind of repeats what we just did. So if I'm looking at 11, I have 5n plus 11n. Both of them share n to the first power. I just need to combine 5 and 11. 5 plus 11 is 16. Keep your variable. Looking at 12, got n plus 4 minus 9 minus 5n. So determine which things can be combined with each other. I'm looking at n. I need another n. over here you have negative 5n. Remembering that the invisible coefficient is what? I need 1 minus 5. That is negative 4. Keep the n. Now you pay attention to what we've left over. Well, coincidentally, a positive 4 and a negative 9 can go together just fine. Both just numbers, no variable. Got to do 4 minus 9, which is a negative 5. $13 pretty much looks exactly just like 12 and 3 that we did. Pretty much most of them are going to look the same from here. I do notice if you look at 14, that is one that does happen to be a smidge different, because despite having 4 terms, if you look, only one of those terms has an n. So it actually can't be combined with anything. So that's going to come down. And then the remaining 3 are actually all just numbers and can go together. So if you've got a calculator, if you want to do it in your head, totally fine. Negative 5 plus 6 minus 1 can all go together. And that actually gives you 0. So instead of, tagging on a plus 0, you can just leave your answer as 9n.